What's up, guys? Welcome back to the channel. Today on this video we'll be doing this question paper that you see here. Now this is mathematics and 4, and this question paper was written on the 27 March 2026 X paper, and it took 3 hours to be written. All right, guys, so we will be focusing on question 2 of this question paper on this video. Just in case you haven't watched question 1, I'll leave that video in the description, and also that video will pop up on the top right of the one that you're watching at the current moment. So before we do question 2, I'd just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the video. Now I'm gonna leave the timestamps for each and every question, just in case you don't want to watch this question in a sequence order. Now we are done with the introduction. Let's look at question 2 and let's solve it. Here is our question 2 there. I hope you can see how I highlighted it. So it has 3 questions: 2.1, 2.2, and 2.3, with 2.2 having 2 sub questions there. So we're going to start with 2.1, and then we're going to create some space so that you can able to solve it. So let's create some space and let's solve 2.1. Alright, guys, here is our question 2.1. Now let's read the statement and let's solve this question. Given here we have x minus 3 divided by 3 plus y plus 4 divided by 5. All this is equaling to 7. So this is the first equation there. And the second equation, we have x plus 2 on the numerator, and they are all divided by 7, minus y minus 6 divided by 2. All this is equaling to negative 3. Determine the value of x and y using the method of Cramer's rule. So we are given these two equations, but they're in fractions. So we need to simplify these two equations. So what you can do here is to find the denominator for each and every equation. So let's start with the first equation there, which is x minus 3 divided by 3 plus y plus 4 divided by 5. All this is equaling to 7. We need to get rid of the fractions. So to make it linear, we need to find the LCD. So to find the LCD here, we have to multiply 3 and 5. This here is 15. There we go. Then we apply the following. We're going to divide this 15 with a 3. We know this is going to give us 5. Multiply the numerator there. So 5 is going to be multiplied by x minus 3 there, plus, because we have plus there. So this time around, we're going to divide this 15 with that 5 there, and then the answer here is going to be 3. So that 3, we're going to multiply it with this y plus 4. So y plus 4, they're going to multiply the 3 there. All of this is equaling to 7. There we go. Now on the numerator, we need to get rid of the bracket. So this is going to give us 5x minus 15. On the second term, we have 3 multiplied by y multiplied by 4. So this is going to give us 3y plus 12. And then we can divide by 15 there. Right. So this is equaling to 7. So from here, we have like terms, and we can also do cross multiplication. So let's start with the like terms. We have negative 15 and 12 there. So this, they're going to give you negative 3. Right? So we're going to write 5x plus 3y. Negative 15 plus 12, this is going to give us negative 3. All this is still divided by 15, equaling to 7. Right? So let's continue here at the top. Now we can cross multiply by multiplying this 15 with 7 there. We're going to have 5x plus 3y minus 3. This is going to give us 7 multiplied by 15. That is actually 105. There we go. And then we're going to transpose this negative 3 to the other side. So it's going to become positive 3. So we only left with 5x plus 3y. And then this negative 3 is going to become positive, right? And then the actual equation is going to be 5x plus 3y is equaling to 108. All right, guys, so this is our equation 1. Now we need to simplify equation 2 there. So we're going to continue underneath. Let me create some space a bit here. So the second equation is going to be x plus 2 divided by 7 minus y minus 6 divided by 2. All this is equaling to negative 3. Again, here we need to find our LCD. So our LCD here, it's 7 multiplied by 2. That is going to be 14. So we start 14 divided by 7. That is going to give us 2 multiplied by x plus 2. So this is going to be like that. And then minus, because we have minus there, guys, right? Then we have 14 divided by 2. That is going to give us 7. So that's 7 here. And then it's going to multiply y minus 6 there. There we go. All this is equaling to negative 3. Now let's remove the brackets. So on the numerator, we have 2 multiplied by x plus 2. That is going to give us 2x plus 4. There we go. And then minus, we have negative 7 multiplied by y minus 6. So this is going to give us negative 7y plus 42 divided by 14. All this is equaling to negative 3. Right, so let's create space, guys, so that we can have our equations there. Now that we have created space, we have like terms here with 4 and we have 42 there. Now it's time for us to add these like terms. So we're gonna start with 2x minus 7y, 4 plus 42. That is gonna give us plus 46. All this is divided by 14, and this is also equaling to negative 3. So from here, we have to do cross multiplication. We multiply this 14 with negative 3, and then we'll have a linear equation. So let's continue. We have 2x minus 7y plus 46, and this is going to be equaling to negative 42. There we go. So from here, we have to transpose this negative 46 to the other side. So let's do it. We have 2x minus 7y, and then this is going to be negative 42 minus 46. Let's zoom down for now so that we can be able to finish this equation. So when we continue here, we're going to write 2x minus 7y. This is going to be equaling to negative 42 minus 46. This is going to give us negative 88. This is going to be equation 2. So let me just create space so that we can able to actually write this equation next to each other. So equation 1 is going to be 5x plus 3y is equaling to 108. There we go. So this is equation 1. So equation 2, it's 2x minus 7y, and this is going to be equaling to negative 88. This is equation 2. There we go. So from here, we can create the matrix in order for us to get the determinant. So when you create the matrix, guys, it's so simple. You only take the coefficient of x and y, and then you insert there on your matrix. So let's start with the first column. So the first column is for x, so we're going to take the coefficient of x. So it's going to be 5 and 2. There we go. And then let's move to the second column. The second column, we only take the coefficient of y, which is 3 and negative 7. As you can see, this now is our matrix. All this is equaling to determinant. So in order for us to calculate the determinant of this matrix, we have to multiply with the first entry and the last entry, and then the product of that entry and the second entry, they will subtract the first product. So let's do it. D is equaling to, this is going to be 5 multiplied by negative 7 minus. So in the next bracket, we're going to multiply 3 with 2, which is the second entry with the third entry. There we go. So if you use a calculator, this is what you're going to get, negative 41. So this here is our determinant. We're going to use this determinant to find our x and y. So from here now, we need to find the determinant for x. So I'm going to write dx here, which is going to be equaling to. So we need also to create the matrix for dx. Now, since we are calculating the determinant of x, we know that x belongs on the first column. So what you're going to do here, we're going to substitute this entry with the constants there. The first entry we're going to take from the first equation, which is 108, and then the third entry we're going to take from the second equation, which is negative 88. There we go. And then we're gonna keep these ones for y because we are not calculating for dy. So we have 3 and -7. There we go. So when you calculate dx, you're gonna do similar thing that you did here. You multiply the first entry and the last entry there. So let's do it. So it's gonna be 108 multiplied by -7 minus. Now you multiply the third entry with the second entry there. So we're gonna have -88. Let me create space here with a 3 there. There we go. So your answer here for dx is gonna be -492. There we go. So we are done with dx. Now it's time for us to calculate the determinant of y. So when you calculate the determinant of y, you also need to create the matrix there. If you create the matrix, now you have to take back these entries of x back there to the matrix. So we have 5 and 2. We're no longer calculating the determinant of x, so they must go back to the original. And then since we are calculating the determinant of y, we have to take the constant and include them on the second column because second column is for y. So here we're going to write 108 because the first row represents the first equation and the second column represent y. So we're going to put that there. And then the fourth entry is going to be -88. There we go. So from there, we calculate dy. dy is going to be equaling to, we multiply the first entry, which is 5, with the last entry, which is -88, right? Minus, and then we're going to multiply the second entry, which is 108, with the third entry, which is going to be 2. Now we put this on your calculator. dy is going to be -656. There we go. So these here are the determinants. They are not yet the actual values. So in order for us to calculate x and y, the following is required. X is going to be equaling to dx divided by d. So we know that we've already calculated d here. We also have dx there. So it's time for us to just substitute. We have -492 for dx divided by d, which is -41. So the final answer here is +12 there. So let's find y. When we calculate y, we're going to do similar there. We're going to have dy divided by d there. So dy, we know that is -656 divided by -41. So our answer here is going to give us 16 there. So as you can see here, our x is 12 while our y is actually 16. So you can check these answers whether they're correct or not by substituting them on this equation or that equation. So I'm going to choose the first one then. So we have 5x. Instead of writing x, we're going to write 12. And then we have plus 3 multiplied by y. Instead of writing y, we're going to write 16 there. So if you put this on a calculator, it should give us 108. So when I do that, I'm actually getting 108. So this proves that our x is correct as 12 and our y is correct as 16. Guys, we have done this type of problems on this channel. You can go to the playlist and search for determinant. I have a playlist that is all about determinant. I'm gonna leave again that playlist on the description, and also the icon at the top there is gonna pop up for the playlist that contains the determinant. All right guys, we are done with 2.1, even though it was a bit long, but we are finished with it. If you have a question based on this 2.1, do not forget to comment on the comment section, and also try to watch at the point where you got confused. Maybe that will help you as well. But if this part of the video helps you to understand, do not forget to like, share, comment, and subscribe to the channel, because we have done questions like this, and also you'll be notified when we upload a video. All right guys, we are done with 2.1. Let's go and do the next question, which is 2.2. All right, here's our 2.2 guys. Now we are given the matrix here. I hope you can see it. This is a 3 by 3 matrix. So let's look at the sub question of this 2.2. We have 2.2.1 They want us to evaluate the determinant. Expand only along the element of row 1. So here on this question, they want you to use row 1 as the reference to get the determinant. So we're gonna highlight row 1 so that we can able to use it. So before we calculate the determinant, this means that row 1 entries or elements, they're gonna be minus. We need to write the signs here. So the signs goes like this. You have positive, negative, and positive. We have negative, positive, and negative. And we have positive, negative, and positive. So these signs, they're going to help us, guys, to find the determinant that they're asking us to get. So let's start. If you calculate the determinant, right, first you have to select from the row 1 as your minor. So when we have minor 3, meaning we're going to cancel the row at which 3 is and the column at which 3 is. There we go. So we cancel the row where 3 is and the column where 3 is. But we can see that this 3 correlates with the positive there. So here's how we're going to write this. We're going to write 3 and then we write the matrix that is remaining there. We are left with 7, 8, 9, and 6. There we go. Then we move to another one. So the next minor is gonna be 2. So we can write minor 2, meaning we need to cancel the row and the column where 2 is. Right. So let's look at 2 there. 2 correlates with negative there. So we're gonna write the negative 2 first, and then we'll write the matrix that is remaining there. We're left with 4, 9, 1, and 6. There we go. Now let's move to the last minor, which is minor 5. There we go. Now from here, we have to cancel the row and the column where 5 is. There we go. Now when you look at 5, correlate with positive there. So this here is going to be plus 5. And then we write the matrix that is remaining there. We're left with 4, 7, 1, and 8. There we go. All right. So the next step from here, we're going to continue like this. We have this 3. So it's gonna be multiplied by the following. We multiply the first entry, which is 7, multiplied by 6 minus, and then we have the second entry multiplied by third entry, which is 9, multiplied by 8, and then we close the bracket there, minus 2, and then we open the bracket again. We have 4 multiplied by 6 is the first bracket, minus by the second bracket, which is 9 multiplied by 1. That is 9 multiplied by 1 there. And then we have the last one for minus 5. So inside the bracket there, we have 4 multiplied by 8. 4 multiplied by 8 minus 7 multiplied by 1. So from here, you use a calculator. Right, so if you put this on your calculator, the first term here is going to give us negative 90 minus, right, 30, like that. And then the last term here is gonna give us 1 to 5. So when you add these together, the answer here, I'm getting positive 5. So our determinant is actually 5. Like I said earlier on question 2.1, we have done determinant. So there is a playlist on the description and on the icon at the top right of this video. Go and click on that playlist. You will see that I've done something similar to this on this channel, or you can go to the playlist and search for determinant and watch each and every video there in order for you to understand better. But if this part of the video help you to understand better, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. If you do not understand, you can also leave a comment or rewatch at the point where you do not understand. All right, people, we are done with 2.2.1. Let's look at another sub question, which is 2.2.2. All right, guys. Now, here's our 2.2. It goes like this. Evaluate the cofactor of element 8. Now, here, they want us to find the cofactor. There is a formula for cofactor. When you calculate the cofactor, guys, it goes like this. Cofactor is equaling to, we have inside the bracket -1 to the power of I plus j multiplied by minor, right? So I'm gonna try to explain what is the meaning of these things here. Let's start with I and j. I and j are basically row and column. If you have a minor, for example, minor, it's gonna be written like this: I and j. There we go. I is actually row, and then j is actually column. So since our element is 8, which is this here, but at which row is our 8? So as you can see, this is the third row there. So we're gonna write 3 there instead of writing I. And then what column is our 8 there? It's on the second column. So we're gonna write 2 instead of writing J there. There we go. So it means that J and I, they're actually 3 and 2 respectively. So if you continue here, we're gonna have -1, right? And then we have I plus j. So we have 3 plus 2 multiplied by the minor. So how are we gonna write this minor? It's very simple, guys. The minor is the matrix that we're going to have when we cancel the row at which 8 is. Let's do it. And the column where 8 is. Remember, 8 is the one that we're gonna use as our reference. So what is it that we left with here? We have 3, 4, 5, and 9, like that, right? So when we continue, we're gonna have -1 to the power of 2 plus 3, that is gonna give us 5, multiplied by, let's continue here, we're gonna multiply the first entry and the last entry there, which is 3 multiplied by 9, there we go, minus by the second entry and the third entry, which is 4 multiplied by 5. Then we close the bracket there. So -1 to the power of 5, that is going to give us -1 multiplied by, inside here we have 3 multiplied by 9 minus 4 multiplied by 5. That is going to give us 7 there. So if we continue here, we have -1 multiplied by 7. This here is going to give us -7. So the cofactor of the element 8 is actually -7. Guys, I hope you managed to understand this. As you can see here, we use a different formula. There is another formula that you can use to calculate the cofactor. So if you want to learn about that formula, you can go to the playlist and search determinant. And then there is a video where I calculate the cofactor using a different method. If this helped you to understand how to calculate the cofactor, do not forget to like, share, comment, and subscribe to the channel. If you haven't subscribed to the channel, subscribe to the channel because I've made loads and lots of videos on this subject. If it so happens that you do not understand, don't forget to leave a comment and I'll try to help you to my level best. And you can also watch at the point where you got lost. We are done with 2.2. Let's go and do the last question, which is 2.3. All right, guys, here is our 2.3. Now, on this question, they want us to simplify the following expression that you see here, and they want us to leave it to rectangular form. They also want us to show all the steps there. So what you're going to do here, as you can see here, we have a fraction and we also have the power there for both numerator and denominator. Now, if I look at the numerator, we have 10 cis 126 degrees. This here is actually polar form. So we can rewrite it like this: 10 polar 126 degrees divided by. And also on the denominator, we have 2 multiplied by cos 72 plus I sine 72. Guys, this is also another notation for polar form. So we can write it in this notation. We have 2 and then we have polar 72. Or you can use the cis notation. It's all good, guys. But let's not forget, all of this has the power of 3 there. It means we need to use De Moivre's theorem. But before you use De Moivre's theorem, we have two complex numbers that are dividing each other in a polar form. So when you have two complex numbers that are dividing each other in a polar form, the modulus, they will divide each other. So if you continue, this is going to be 10 divided by 2, and then polar, we have 126 degrees. The one on the numerator, when it comes to the argument or the angle, is going to be positive, and the one on the denominator is going to become negative there, which is 72. But let's not forget, all this is the power of 3. So let's continue. We have 10 divided by 2. This here is going to give us 5. And then we have 126 minus 72. This one here is going to give us 54 degrees. Let's not forget, all of these, they have the power of 3. Now we can start using the De Moivre's theorem. Now with the De Moivre's theorem, I'm going to do it here on top. The modulus, which is 5 there, is going to have 5 to the power of 3 there. And then as for the argument, which is 54, is going to be multiplied by 3 there. So if you continue, 5 to the power of 3, we know that this is going to be 125 there. And then we're going to have polar 162 degrees there. Right. Now, remember, they want us to leave this in a rectangular form. If you don't know rectangular form, guys, we have a real number and imaginary number. So in order for us to convert this to rectangular form, we need to use the formula that was used here. So let's go back. Now we're going to have 125, right, multiplied by cos 162 plus imaginary sine 162, right? So what you're going to do here, we're going to multiply throughout with 125. 125 multiplied by cos 162, I'm getting negative 118,88. And then I will multiply this 125 with I sine 162. So what I'm getting here is positive I 38,627. There we go. So this here is a rectangular form. We have a real number here and we have an imaginary number there. So guys, this is how you solve this question. I hope you guys managed to understand how to solve this type of a question. As you can see here, we use the De Moivre's theorem, and also we divided complex numbers in a polar form. And lastly, we converted from polar form to rectangular form. Again, I'm going to leave a playlist that contains all the methods that we use to solve this problem here on the description, just in case you want to learn about them. And the very same playlist is going to pop up on top of the video that you're watching at the current moment. So guys, we are done with 2.3. If this question helped you to understand how to solve this type of problems, do not forget to like, share, subscribe to the channel if you haven't subscribed. And also you can comment on the comment section. If you did not understand, go to the playlist and watch the videos. And if that doesn't help, you can always watch at the point where you get confused. Thank you very much for watching. We are done with question 2. Next video is going to be on question 3 of this question paper. Till next time, guys. Cheers.